everyone. Myself Dipti Gusse as Assistant Professor in School of Computer Engineering at MIT Academy of Engineering, Anandi, Pune. Today I am demonstrating time series forecasting using LSTM. The LSTM means that is a long short-term memory. Here in this demonstration, I am explaining the univariate LSTM approach, where is the target variable, only one target variable, using for the prediction purpose. Now here these are the libraries required like TensorFlow, Matplotlib, NumPy, Pandas, OS. These libraries are required today for implementation of time series forecasting using LSTM. Now here I am uploading the data set directly. I am referring this data set from the website. Now once the data set is downloaded, now here unzip the file and this data set is ready for the pre-processing. Now this is the temperature data set. Now in temperature data set, this is the index, this is the date and time. Now here the temperature record is taken after every 10 minutes per day. Here total 144 record readings will be taken, and for 5 days 145 by multiply for 44 multiplied by 5, 720 record readings will be there. Now here these are the remaining columns. Now here, as this is the example of univariate LSTM, so here only one column will be considered, that will be temperature along with the date and time. Now in LSTM we are this is the example of time series forecasting, means we are collecting the data sequentially and predicting the next day temperature. Okay, now here we are predicting the temperature in degree Celsius in future. Now here data set is revised. Now here date and time data set along with the temperature value. Now here you can also see the graph. You can plot the graph for the selected data set. Now here this is the univariate data set. Now here NumPy convert into array value. Now here we are splitting this data set. Now here what a data set, first 3 lakh value will be observation, will be the training data set, and remaining data set will be considered as a testing data set. Random seed is equal to 13. Randomly we are here changing the values. Now here train and test data set. Now here whenever we are using any value data set in CSV, at that time normalization is required. So here we are normalization using mean standard value. Mean standard value will be calculated for the training data set, and here the data set will be normalized. Once the data set is normalized, now here one function is defined, that is the univariate data. Now whenever data set is used, now after pre-processing, the data set should be transformed into sequence. Okay, transferred into series of sequence. Series of sequence means, suppose here there are total 3 lakh records are there. Now we need to create a sequence of 20 days temperature. Now from first record to 20 records will be considered, and 21st record will be considered as the next predicted result. Means we are predicting next day temperature based on the last 20-day temperature. So here data set will be the input, that's the training data set. Start index, start from the 0. End index, that is the size of training split, 3 lakh will be the end index. History sizes, now here in this example history size is equal to 20, means based on the 20 record we are predicting next record. Now target size is only next future day 1 record we are predicting. If we are predicting next 5 future day record, means the target size is equal to 5, but in this example target size is equal to 1. Okay, for predicting the next 21st record, we are focusing on last 20 records. Okay, once the function is defined, now we are calling this function. Now univariate history is equal to 20. Now univariate data set, 0 is the index value, train split is a index, univariate past history, that is 20 records. Based on the 20 record we are predicting next record, and univariate future record is target is equal to 0, because here the past history record we are displaying in this format. You can see these are the 20 past record, minus 20 to minus 1, and plus 1, that is the next record will be the 0. So here next record is target is equal to 0. Once you call this function, now data set is prepared, training data set and testing data set. Now, once you convert the data set into feature sequence, that in series sequence, now 20 here arrays will be created where the array size is equal to 20 and next target size is equal to 1. Means based on the 20 record, we are predicting next. So, whatever 20 records are there, next value will be the predicted result in training data set. Now here, these many 2,99,980 records are created. Now here, after displaying these all training and validation data set shape, now here next we'll move towards the time step value. Now here even user defined function create time step is defined. The length is 20 and here it will display in negative value, means that last 20 days value plus 1, that is a 0 size, 0 value is plus 1 is equal to 0. 0 is the target size in a LSTM for prediction purpose. Now based on the previous 20 days, we are predicting the tomorrow's value. Next day value. Now here this function to plotting the graph to display the all values, training and testing. Now here one array is created where the size of array is 20. In this way there are 2,99,000 arrays will be there where the size of array will be 20 and this is the array value, and next one value, this will be the next predicted value for this 20 record. Next predicted value will be, the label will be minus 2.10. Now here all these values are plotted in a graph. Now for one array, these values are plotted. This is the plot for the one array. This is the history and this is the true future. This is the minus 20, 1, 2, 3, minus 1, and then plus 1, 0 value. This is the target. Now here this is the true future value. Now here we need to implement LSTM algorithm to predict the next day temperature. Okay. And this is the true future, this is the label value, and then we need to compare the true future value and predicted result, that will using the loss evaluation matrix. Now let us discuss how we are using LSTM function for prediction. Now here one more function you can use to generate the data set into time series sequence, that is the from tensor slices method. You can generate the data set in series. Now here this is the main code, this is the main model where we are adding sequential model. Now here TensorFlow.Keras model, sequential model adding, where the number of layers we can add one by one. Output of the one layer will be the passed to the next layer. Now here layer LSTM is added. Now in LSTM there are total 8 hidden layers are there. Input shape is equal to, that is a training shape, that is a training shape, that is that there are 20, this one array of 20 atom, and next predicted value 20, 1 will be the one input will be passed to the LSTM in each each time step. Now here we are predicting only one value, so in dense layer we are added only one neural, means we are predicting only one target size, one next future day temperature. Okay, now here optimizer, in compilation we are using Adam optimizer, and MA will be the loss evaluation matrix. Now here we are training this model for the 200 epoch. After 200 epoch, you can see the loss is decreasing towards the 0. Okay, and then you can check the validation prediction result. Now this is validation prediction. You can pass the value, take any random 5 input from the data set, then you can pass any 5 array from validation data set, and you can display the result. Now here you can see here for this example, now for invalidation result history, this is the minus 20 to minus 1. Actually this is the true future value, but the value is displayed here. That's the model prediction. Okay, now here we need to calculate the difference between these two values, that is called as the loss of model. Same here, you can display the value for all validation data set, and you can check the performance of the algorithm using loss evaluation matrix. This is all about demonstration of time series forecasting using LSTM model. Thank you.